In this example, we are trying to use linear approximation to get an idea what this cube root of 2 is and the cube root of 26, and then we'll talk about are these overestimates or underestimates, and then we'll see how close we are to what the actual answers are. So the idea of this came prior to having calculators to do all of this stuff for us. So it would be an easier process of getting a way of figuring out what's a quick estimate. By quick, that's kind of relative. But first, actually figuring out what the cube root of it is a pretty lengthy process. So this would have been a more efficient way rather than going through the whole process of actually figuring out what it is. So linear approximation is we are going to be creating tangent lines. Tangent lines are going to look like this at a point that's close to this, and that's close to this. So what we're going to do is we're going to do a couple layers to this. Is we're going to first talk about the fact that we're dealing with cube roots. So cube roots are what we're doing. We're basically finding points on this cube root graph. So our equation that we're messing with is a cube root. Okay, so what I want to do is I want to start taking the steps to build a tangent line. So to do a tangent line is I need my slope. So I'm going to write this into something that is more derivative friendly. So then I'll do my derivative so I can find my slope. So 1/3 would come down, and then I would subtract 1 from it, giving me a -2/3. So if I rewrote that, my slope equation is going to be 1/3 times the cube root of x squared. All right, so that's my slope equation. So if we start off with 2, all right, we're going to cube root the 2. If I were to plug it in, we'd be cube rooting 2. So what I want to do is I need a point that's close. And I don't need any point. I need a point that I can actually do the cube root of nicely. So if I could either do cube root of 1 or the cube root of 8. Those are going to be my perfect cubes, but I want to pick the one that's closest. So I'm going to use 1. All right, so what I need to do then is to figure out my tangent line. I'm creating a tangent line based on a point that's close to this. So I need a slope and I need the full on the rest of the coordinate. So let's plug in to figure out the coordinate. So it's the cube root of 1, which is 1. So coordinate is 1, 1. Our slope at 1 is this. So 1/3 times the cube root of 1 squared, which is going to get us 1/3. So then I can build my tangent line. So y minus my y1 equals 1/3 x minus my x1. So I distribute, add my 1/3 x minus 1/3. And if I add 1, I'm looking at y equals 1/3 x plus 2/3. So there's my tangent line. So visually, here's what we got going on. Okay, a cube graph looks something like this. Here's 1, here's 2. So if I were to do a tangent line, I would be looking at something like that. So what I'm doing is I want to figure out roughly what this value is, but I'm going to plug it in because I don't know how to cube root this without just plugging it into a calculator. But what I can do is I can plug the 2 into my tangent line, and it's going to give me that y value, which is a little bit of an overestimation, but it's reasonably close, right? So the real value is going to be here, but our estimation based on plugging it into this tangent line is going to give us a value reasonably close to it. So if I plug in now x equals 2, we got y equals 1/3 times 2 plus 2/3. And so we're looking at y equals 2/3 plus 2/3. So our y value is 4/3, which is 1.5. 3, 3, 3, on and on and on. Okay, so what we're saying is our estimation of the cube root of 2 is 1.333, on and on and on. All right. The actual cube root, let me cut it off at 3 decimals. The actual value, because we do have a calculator, the actual value is 1 point. Right? So 1 point, oops, that's a square root. Let's do cube root of 2, 1.2599. So 1.260. So 1.260. So not bad, but how far off are we? Right? So we know that this is an overestimate. I knew that because of my graph of this is the value that I'm getting, and this is what the real value would have been, kind of the shape of it, the concavity of it. So I knew I had an estimate, and I knew that it was an overestimate. But how close, oops, how close are we? Right? I knew it was an overestimate, but how close are we? So if we take that value divided by this value, 1.333 divided by 1.260, right? I'm going to get 1.058. If I did that math on here, I get 1.058, subtract the 1, that would be 5.8% over. So actually not amazing, right? But that's the closest perfect cube that I could get to it. So let's do the same idea with the cube root of 26. So good news is we already found the slope equation for anything on this cube root graph. So we've already done that math. We need a point that's close to it. That's a perfect cube. And then we'll plug that in, create our different tangent line because we're at a different point, and then we'll get our estimate. So we're doing 26 is the value that we're focused on. We need a point that's close. Need point that's close. So perfect cube would be 27. So if I cube root, if I plug in 27 and I cube root that 27, I'm going to have f of 27 is going to be the cube root of 27, which is 3. So when I plug in 27, I'm getting 3 out. Right, so I'm going to make, I need my slope. So I have my x and y value. I need my slope at that point. So my slope equation is right here. So 1 over the cube root, 3 times the cube root of 27. Now I'm going to square it after, not before. So the cube root of 27 is 3, squared is 9, times the 3 is 27. So it has a slope of 1 over 27. All right, so our tangent line, same idea. We're going to plug in our values, plug in our slope into our tangent line. So y minus the y value of 3 equals 1 over 27, x minus 27. So y minus 3 equals 1 over 27, x, oops. Distribute again here, so that would be a 1. Add 3. So our tangent line is 1 over 27, x plus 2. All right, so visually, again, what we got going on is this graph. Now we would be zoomed out quite a bit more, so more like that. So we would be out here at 27, creating this tangent line like that. And we're trying to figure out what 26 is. So this time we're really close to it, but this cubic is still below it. So our answer that we'll get is here. The real answer is just a smidge below it. So we're an overestimate because our value is going to be on the tangent line, which is above it right here. But we're way closer, I feel like, than what we got on this one. So let's find out. So if we plug in 26, you would be doing y equals 1 over 27 times 26 plus 2. All right, so what I get out of that, I have to plug in a calculator. So I get a y value of 2.963. So we are saying that our estimation of the cube root of 26 is 2.963. That's what our estimation is, which we know it's an overestimate. Right? Because we know that that tangent line is above that cubic graph. So it's an overestimate, probably awful close. All right, so there's part of our answer. The real cube root of 26 is, if I throw this one into the calculator, 2.962. So we are amazingly close this time. So if I now take that same 2.963 divided by the real 2.962, I would get 1.0003. If I subtract the 1, that equates to move my decimal 1 to a 0.03% over. So, and that had everything to do with the fact that here we were on more of a curve, where here it had flattened off on that cube root graph. And so any of these points that are going to be close, especially if it's really close to your perfect cube that you're using for your estimate, you're just going to be way, way accurate on it. So that is us using linear approximation to estimate some values that prior to calculators, it would take quite a bit of work.